Example 3. Determine the magnitude and location of the resultant force acting on the triangular end plate of the settling tank in the figure. The tank contains kerosene. Now, although in the problem it is not given for our upcoming examinations, I will sure to provide the relevant densities of the fluids. Okay, because those are constant, so you don't have to memorize all of that. Okay, so I will make sure to provide the densities. So for this problem, it's kerosene. So if you have, let's say, a manual or some sort, the density of kerosene is 814 kilogram per cubic meter. Okay, so we write what is given. So the plate is triangular. So initial assumption would be plate is triangular. Okay. And then the base, which is this side here of the triangular plate, is equal to 1 meter. And then the height from the base to the tip, or let us have that in terms of the size of a triangle, let us have it as A, is equal to 2 meters. Okay, and since the fluid is kerosene, so we write density of kerosene is equal to 814 kilogram per cubic meter. The same, we are tasked to find for the magnitude and location of our resultant force. So what is required? F sub R and the center of pressure. So our solution we write. Now, since the entire tank is triangular, right? The centroid of this plate here, this triangular part of the tank will have a centroid following the formulas uploaded in the rule classroom. Okay, so we'll find the cent centroid first. So the formula would be y sub c is equal to, for a triangle, if from the base here, if this is our triangle, from here to our centroid, that is 1/3, and from the centroid to the tip, that is 2/3. Since the surface is triangular, the base of is at the top, so therefore we will be using the 1/3. And the total height is 2 meters, so therefore this is 1/3 times 2 meters. So you can opt to express them into decimal, or you can just have it as your y sub c, or your the depth of your centroid is at 2/3 meter. Okay. So for our F sub C, no, sorry, F sub R resultant force, the magnitude of our resultant force, that is gamma times our Y sub C, or in some books they use H, right? So let us stick with what is conventional. We use H. A is equal to 814 for our density times 9.81 times now our centroid 2/3 is also the depth of that centroid. So we will multiply it with 2/3 meters. This is in meters. Now for our areas, of course, the area of a triangle is 1/2 base times height. That is times 1/2 times the base, which is 1 meter, times the height, which is 2. So our magnitude of our resultant force is equal to 814 times 9.81 times 2 divided by 3 times 0.5 times 1 times 2, which is 5,323.56 Newton. So this is our magnitude of the force of our resultant force. Now we are fine for our center of pressure. Center of pressure, CP, which has, of course, x sub p, y sub p coordinate. Now for our y sub p, this is equal to the height of our centroid, the depth, which is y sub c, plus our uh, moment of inertia, formula for triangles, divided by y sub c times our area. Now, this is 2/3 plus, right? Our formula for I sub x for triangular plates, that is I sub x is equal to a cube b over 36, wherein our a is the height from the tip. This is our a, and this is our b, meaning the measure of our base. So a cube b. So this is our a is, like I said, is 2. So let us substitute that here. 2 cube times 1 divided by 36 all over 2/3 times the area, which is 1/2 base, the base is 1, base times height. So our y sub p is equal to 2 cube times 1 divided by 36 is 0.2 repeating, divided by 2 close parenthesis 2 divided 3 times 1. It's 0.3 repeating plus 2 divided 3, that is 1 meter. 1 meter from, of course, from the surface. And our x sub p is equal to 0 because your triangle as well is symmetric about the y-axis. So that is example number 3.